Lesson 5.1 is on polynomial equations. The objective for this lesson is we're going to be able to sketch graphs of polynomial functions. We're not going to do anything with this second one here, identifying zeros, but we will also identify end behavior. Alright, so we're going to hit the two objectives that I highlighted in yellow there. Essential understanding, you need to know the vocab. So monomial, what is a monomial? It's a real number, a variable, or a product of a real number and or one or more variables with whole number exponents. Alright, that's a lot. So let's make some sense of that. So examples of a monomial. It's a polynomial with just a single term. So 5 is a monomial. X is a monomial. 3x squared, 8x to the third, 12x to the eighth. Those are all monomials because it's a polynomial with a single term. Now the degree of the monomial in one variable is the exponent of the variable. So the degree here, there is no so the degree, it's a so 5 is a constant, so the degree is going to be 0. This is x raised to the, if there's nothing there with the variable, alright, it's understood to be 1, so the degree is 1 there. 3x squared, the degree would be 2. 8x to the third, the degree would be 3. And then 12x to the eighth, the degree would be 8. Okay, so if you notice, the degree, okay, like the definition said, it's the exponent of the variable. And if a variable, like I said for this one, x, if like the variable x, if it doesn't have an exponent, it's understood to be 1. Okay, now a polynomial. Okay, is a monomial or the sum of monomials. So a polynomial could be a monomial, like we just listed, or the sum of them. So for instance, x plus 2 would be a polynomial. It has two terms. 3x to the third plus 8x plus 1. That's another type of polynomial. Alright. It has three terms. Okay. So a polynomial again is a monomial or sum of monomials. So, and then finally the degree of a polynomial is we look at the highest power of your variable. So we look at x, it's raised to the first, so the degree here would be 1. Here, the highest power of x, so we have an x to the third, we have an x to the first, and then our constant, so the highest power of x is 3, so that's what our degree is. Okay? Okay. I should also point out a polynomial function, that last part there. All it is a polynomial that has, you know, like a p of x equaling or an f of x equaling. It's just a notation. So a polynomial function just has, you know, the p of x or the f of x equaling in front of it. Right, so nothing to be really too concerned about. The standard form of a polynomial function arranges the terms by degree in descending numerical order. Alright, so this is important. So standard form, and we've talked about this before. So if we look at this polynomial right here, this polynomial function, we have 4x to the third plus 3x squared plus 5x minus 2. So notice that the exponents, 3, 2, 1, and then our constant, notice how it's written in descending order. All right, that is standard form. Okay, so it's important that when you get a polynomial function or a polynomial, you want to put it in standard form first. All right, so an example of something not in standard form, we can write 4x to the third plus 3x to the sixth, minus 8. Oops. Just erased it. Sorry, guys. Okay, so f of x equals, what did I have? 4x to the third plus 3x to the sixth minus 8. This is not in standard form because notice how it goes from 3 to 6. It's not written in descending order. So we'd have to correct that and rewrite it as 3x to the sixth plus 4x cubed minus 8. Alright, so it's important. Put it in standard form. Okay, we're going to be referring to this chart here. This is really going to help you in this lesson, especially with problems like problem 1 that we have when we're trying to classify polynomials. So in problem 1 it says, write each polynomial in standard form. What is the classification of each polynomial by degree and then by the number of terms? Alright, so let's tackle the first part. Put it in standard form. So if we look at A here, it's not in standard form. The exponents are not written in decreasing order, so we're going to have to change that. We're going to have to change it to 9x squared plus 3x plus 5. Okay, so now it's in standard form. Now it says, what is the classification of this polynomial by degree? So what is the degree? So the degree is the highest power of whatever of the variable. So it's going to be 2. So the degree is 2. And then what's the number of terms? So how many terms are there? Well, there's 1 term, 2 term, 3 term. Alright, so it's a degree 2 with 3 terms. Now I'm going to come over to this chart. So a degree 2 is called a quadratic. So this polynomial is quadratic. And then it has 3 terms. So 3 terms means it's called a trinomial. So in part A we have a quadratic trinomial. Okay. Change colors for the second part, B. So we have 4x minus 6x squared plus x to the fourth plus 10x squared minus 12. So what I notice right away is I can combine like terms here. I also see that my highest power of x is going to be 4. So this is not written in standard form. So let's do that. So we're going to put an x to the fourth first. And then I have a negative 6x squared plus 10x squared. I can combine those to give me 4x squared. And then plus 4x minus 12. Alright, same steps as before. Write down, or write what the degree is. So the degree is the highest power of x. So in this case it's going to be 4. Alright, the number of terms. Well, we have 1, 2, 3, 4 terms. Alright, so now I'm going to come over to our chart. So a degree 4, so a degree 4, this is quartic. And then 4 terms. So if it has more than 3 terms, so it has, it's just a we say it's a polynomial of however many terms it actually is. So this is going to be a quartic polynomial of 4 terms. Okay. So those are the 2 answers. Okay. So now what I want you to do, hopefully you got a hang of this. So again, I was looking how many, there's 4 terms, so I'm looking here. So now hopefully you got a hang of this. I want you to go ahead and hit pause, and then I want you to do A and B, on your own, and then when you're finished, hit resume and check your answer. Alright, so for A here, we have a degree 4 polynomial with 3 terms, so it is called a quartic trinomial. And then for B, we have a degree 5 polynomial with 3 terms, so it's a quintic trinomial. Alright, so hopefully you guys got those correct. On to the next part. Okay, what I want you to do is add this part somewhere on the guided notes. So we know that if the polynomial is degree 0, it's going to be a constant. So what does the graph of a constant look like? Well, it is a horizontal line. Alright, so that would be, an example, y equals 5. Okay, if the degree is 1, that polynomial is linear. What does that graph look like? Some sort of slanted line. So an example, y equals x plus 2. If the degree is 2, the name of this is a quadratic. Alright, the graph of a quadratic, remember from last section, is U-shaped, last chapter. And an example equation would be y equals x squared minus 3. A degree 3 is cubic, and it looks sort of like a snake. And an example would be y equals 3x cubed plus 2x. Okay, so essentially what the purpose of writing this is you can, based on your equation, you can tell what the graph is going to be. Based on the degree, you could tell what the graph is going to look like. Alright, so the equation can tell you the degree, and it tells you what the graph ends up looking like. So all degree 3 polynomials, they look snake like that. All degree 2 polynomials are parabolas, they're U-shaped. All degree 1 polynomials are linear, they have a slanted line. All degree 0 polynomials, they're constant. Alright, so they have just a flat line. Alright, so you can learn a lot about the shape of the graph based on the degree of the polynomial, so that's important. Okay, so as I just showed you, the degree of the polynomial function affects the shape of its graph. and determines the maximum number of turning points or places where the graph changes direction. It also affects the end behavior or the directions of the graph to the far left or to the far right. The turning points, we're not going to worry about that, but we are going to focus on how the degree affects the shape. We just showed that, and the end behavior. All right, and for this, for problems like problem number 2, we're going to focus on this chart right here. Okay, so in problem 2 it says consider the leading term of each polynomial function. What is the end behavior of the graph? Check your answer with a graphing calculator. Alright, so we look at A. We want to first make sure that it is written in standard form, and it is. Okay, and so what is the end behavior of the graph? Well, for the end behavior, we need to look at two things. We need to look at our A and determine if it is positive or negative, and then we need to determine if the degree is even or odd. So our A is the coefficient of our leading term. So our A is going to be 4. Is 4 positive? The answer is yes. So A is positive. And then our degree, what's our degree? It's 3, and that is odd. Okay, so we come, okay, and we look. Alright, so our A is positive. So we're looking in this top row. And then the degree is odd. So right here. So the end behavior is going to be down and up. So what this means is I'm not going to graph it like that. What this means is our graph is going to start down and end up. Now, a degree 3 polynomial, we said that it looks like this. So that's what the graph's going to look like. So this is a degree 3, so it's going to look snake like that. It's going to start down and end up. So this starts down here and it ends up here. Okay? Now we can kind of see an example right here, y equals x cubed. So this is an example where, a specific example where your A is positive and your degree is 3 and it's odd, and so you can see it starts down and ends up. So that's what the end behavior is. So your end behavior you would say down and up. Okay? Alright, we gotta get rid of, gotta create some more space. Let's erase this and go to the next one. Okay, so for part B, okay, your A is negative here. And then the degree is 4, and that is even. Okay? So, since your A is negative, we're going to look down on the bottom row, and then our degree is even, so this is going to start down and end down. So degree 4 starts down, it's it's going to look something like that. It's got a little bump there. Alright, so starts down, ends down. That's what the end behavior is. So down and down. Okay. You can see the opposite here. So you have a degree 4. So the degree is even and it's 4, but your A is positive. So in this case, it starts up and ends up. For part B, our A was negative, so it starts down and ends down. Alright? So go ahead now and hit pause and see if you can do the last problem here under the got it section on your own. When you're finished, hit resume and check your answer. Alright, so your A is negative, so it's negative 4. Your degree is 3, and that is odd. So our A is negative, so we're looking at the bottom row. Your degree is odd, so we look here. So up and down. So up and down is your end behavior. So if we were to sketch this, we know because it's a degree 3, it looks like a snake. But that's if it's positive. So if it's negative, if your A is negative, it's flipped. So notice how it starts up and ends down. So that's the effect of your A being negative. Alright, and you can look here. I don't know if you guys see that, but it's y equaling negative x cubed plus 2x. So notice it starts up and it ends down, and it has this snake-like shape to it. Alright, so that wraps up the first section in Chapter 5 on polynomials. So hopefully you can classify polynomials, and then you can identify what the end behavior is. And I'll be glad to answer questions in class tomorrow.